When people hear about electricity transmission, they usually think of AC power because it has been used for more than a century. However, as power systems grow larger and more complex, engineers around the world are increasingly choosing HVDC instead of traditional HVAC, especially for long-distance transmission. This video explains the real differences between HVDC and HVAC, not from a textbook perspective, but from practical engineering and system-level experience. A short reminder of what HVAC. As we know, HVAC means high voltage alternating current, which is the traditional method used in power grids. Electricity changes direction 50 or 60 times per second, depending on the country. HVAC works well for local and regional transmission, dense interconnected grids, and short to medium distances. For decades, HVAC was the only realistic option. But that changed when power electronics matured. If we ask what makes HVDC different, unlike HVAC, HVDC uses direct current, meaning the power flows in one direction only. This simple difference creates major technical advantages, especially when electricity must travel hundreds or thousands of kilometers under the sea and between weak or isolated grids. HVDC is not about replacing AC everywhere, it is about using the right tool for the right job. The real problem with long-distance HVAC at long distances, HVAC systems face several hidden challenges that are rarely explained clearly. These challenges like reactive power and charging currents, stability limits, and higher losses over distance. If we ask why engineers prefer HVDC for modern projects, the answer will be precise power control. HVDC allows operators to control power magnitude, direction of flow, and ramp up and ramp down speed. This level of control is impossible with HVAC without complex compensation systems. The second reason for why engineers prefer HVDC is integration of renewable energy such as wind and solar. These renewable sources are intermittent and often located far from load centers. The third reason is connecting different power systems. HVDC can connect 50 Hz and 60 Hz grids, strong grids to weak grids, and mainland systems to islands. This flexibility is one of the most underestimated advantages of HVDC. If we ask, is HVAC becoming obsolete? No, HVAC will always remain essential for distribution networks, urban grids, and short-distance transmission, but for long-distance, bulk power transfer, and renewable energy corridors, HVDC is simply the better technical and economic choice. Conclusion: the comparison between HVDC and HVAC is not about old versus new technology. It is about system requirements. When distances are long, cables are used, or grids must remain stable under high renewable penetration. HVDC is no longer optional, it is necessary. If you want to read the full article, you can visit my blog. The link is in the first comment, which was by Abdelazim Saeed. Thanks for watching.